Of what I'm describing today, variables on both sides might look like something like this. The number 20 added to 7 times a number is equal to 9 times the number. What's the number? Well, your goal whenever you're solving equations that have variables and numbers all mixed together is you always want to have a variable, one of them, being equal to a number or a solution, if that makes sense. So right now I have number variable equals variable. I need to get it so that one variable equals a number. And the process of doing that involves collecting like terms. In this case, we're going to collect all, everybody should be taking notes, all of our variables on the right. The reason I like to do that versus the alternative is, first of all, I like to keep my variables positive if I can. You don't have to, you might not need to. No matter what way you do it, no matter what way you move the numbers and the letters, you'll end up getting to a place where your answer would be the same. But this is just the simplest. Leaving you with 20 being equal to 2x, dividing out your coefficient, because I don't want to know what two of the variables are. I want to know what one, and this happens to be an x. I want to know what one of them is. So if I cut that 20 in half, I get 10 being equal to the value of the variable. And that does make sense. 20 added to 70 does equal 90. You can check yourself that way. Addition is the exact same way. So we did the opposite. This was adding 7x, or because it was a positive, we subtracted it. We did the opposite. Example 2 shows us that even if it's a slightly different configuration, you're still utilizing all of the same steps that you've done in the past. Making a decision how to maneuver stuff around. I'm going to move my t's so that they're all on the left, giving us something that looks like this. I don't want to know what 10 t's is equal to. I want to know what one of them is equal to. So I will divide the 10 t's up so that I am able to find out that one of them is equal to 5. And that's true. 4 times 5 is 20. 20 is equal to 60 minus 30. What if it's fractional or division? That's where example 3 comes in. And remember, your book has further examples. I'm providing you with additional examples. So here's my example 3. 3/5 x is equal to 4 minus whatever 8/5 x is. There's actually a couple of different ways to solve this. The way I'm teaching you right now is kind of the first step. There's another way you're going to learn later, and you're probably going to love it. If you're interested, I can show you what it is after. It eliminates the fraction. Anyway, we're going to get all of our variables on one side by adding them. By adding that. Stay with me. What that does is it leaves me with 11/5 x being equal to 4. You would like to divide, just like we did here, 10 t's, 11/5 x's, but we can't divide by fractions, but we can multiply by their reciprocals. You always hope when you multiply by a reciprocal that it allows you to be able to cancel. In this case, it doesn't. The answer is 20/11. 1x, because 5/11 times its reciprocal is 1, is equal to 20/11. Okay, that's example 3. Go ahead and look at your book for a minute. Examples 5 and 6. Take a look at them for just a brief second. The book examples of 5 and 6 are bigger, maybe a little more distributing, etc. I'm sorry, 4, 5, and 6. Look at examples 4, 5, and 6. These are bigger, a little more distributing, but what we're going to introduce or remind you of is that a little more work doesn't mean anything. No big deal, we can do that. Example 5 reminds us of no solution. The book also gives you the word empty set, but if you write NS, I know you mean no solution. The book also introduces a term of all real numbers, all numbers. In 6, that's how we learned it last year. The book also calls it identity. So 4, 5, and 6 is the last couple things I'm going to go over with you. Examples 4, 5, and 6. Example 4, here we go. 7 multiplied by a minus 2. Nope, I'm copying the book example like a dinghy. How about this one? 4 multiplied by r minus 9 plus 2 is equal to 12r plus 14. We're going to have to distribute our 4. The 4 is going to get distributed over the r and over the 9. 4r minus 36 plus 2. The 2 is still hanging out. Now, I'm only writing repeat, repeat, repeat kind of as I go down because it helps me to make sure I don't make any mistakes. And I still do. But it helps me to visualize possibly where I made a mistake if I notice something looks weird. Let's combine like terms. These would be our like terms. 4r minus 34 is equal to 12r plus 14. We now have letters and variables on both sides. Letters or variables and numbers on both sides. Remember how I said I want to keep my variables positive if possible? For that reason, I'm going to move my 4r to the right. And some of you might do all of this in one step, but I'm only showing you just to make sure it's clear. I'm going to move my numbers to the left and divide by my coefficient of 8. R then equals a negative 6. If I were to plug that in, I would plug it in where the R is. And that's here and here. Last year you guys were asked to check in that blue book. This year it doesn't. Example 5 introduces the term no solution. Empty set. A problem has no solution when whatever is on the right does not equal whatever is on the left. Okay? If you get to the bottom of an equation and you come to that, that means your problem has no solution. You would find when I did these, I would write NS. Okay? Again, to repeat, a problem has no solution when what is on the left and what is on the right are not equal to one another and yet are being connected by this equal symbol. That's not true. 6 does not equal 5. Here's what one of those might look like. 3 multiplied by x added to 2 minus x equals 2 multiplied by x plus 1. Okay? Start by doing all the normal stuff you're going to do. Distribute, collect like terms, 3x plus 6 minus x, 2x plus 2. All of this is stuff you've sort of already done. Collecting like terms, you end up with 2x plus 6 equals 2x plus 2. Right now, some of you might start seeing that something doesn't look right here. 2x and 2x equal one another. Why? Because whatever x is for one, x is for the other. But 6 and 2 do not. So I already kind of can suspect that I have a no solution scenario going on here. But just to illustrate it a little better, I'm going to try and combine my x's. That cancels everything out, giving me this. No solution. No solution. Okay? A number equaling something that is not itself means no solution. I want to show you another problem that you might think is no solution. Okay, this is a really simple version, but I had to come up with one. Now that you know the term no solution, a lot of you are going to look at this and think, well, that's got to be no solution because 2 and 2 equal one another, but 4x doesn't equal anything. And if I go through and I attempt to solve it, I now have 4x being equal to 0. And if I divide 0 into 4 groups, x equals 0, I have students telling me all the time that that means there's no solution. That's not true. X is equal to 0. Test it. 4 times 0, which is 0, added to 2 does equal 2. Be very careful that even when you have a 0, if you go and divide it, 0 divided into a bajillion groups is still 0. That is a real, legitimate answer. Be very careful that you don't write no solution when actually there is an answer. Sometimes, unfortunately, anything works. Here is one such example. 1/3 of the difference of 12x and negative 21, 12x and 21, is equal to 4x minus 7. Distribute your 1/3, and you're going to end up with 4x being equal to, what, negative 4x minus 7? Oh, look. Everything on the right matches everything on the left. Now, bear with me here. This might not look clear to you. You might think, well, is it no solution? Is it all numbers? Is it no numbers? What does this mean? Keep going. Some of you might already know it's all, but let's try and get all of our numbers on the right. Well, that makes 0. And all of our letters on the left. That means I've ended up with 0 being equal to 0. Is everybody seeing that there? Is this a true statement? Yeah. Yes. In every sense of the word, 0 does equal 0. And when what you have
calling the International to the office, you'll be waiting for the day,
is identical to what you have on the other side, then your answer is going to be what they call all real numbers, or just all. Okay? All real numbers. When right is identical to left, your answer is all real numbers. So you've got this type of a scenario, and it's because of this, versus, I'm going to go back to the other example, this type of example, which means that. Don't worry, guys, we're almost done. Okay? Be very, very careful. If you come up with all numbers, if I were you, I would test maybe a 1 and a 0. 0 and 1 are always easy to test. If you come up with something is equal to something else and it's a bold-faced lie, no solution there. There's no solution there.